All right, ladies and gentlemen, welcome back to another video with Mr. Kenton, and I've got some good news for you. After today's video, we're going to be done with videos and the Unit 4 stuff on bonding and naming. So that's exciting. That means we're going to be moving into a new set of topics, and we're actually going to be leaving chemistry and talking about physics. So I don't know how you feel about that. Maybe you're like, oh, I really like the chemistry. Or maybe you're like, oh my goodness, I'm so glad we're going to be done with chemistry. I can't wait. Wherever you lie, let's finish up this last video by talking about how do we write chemical formulas when we're given the name. And specifically, I'm going to focus on ionic formulas in this video because those are the harder of the two. And I think these are the more applicable that we need to take a look at. Now, remember, if we're dealing with ionic formulas, that means we're going to be dealing with compounds that contain a metal and a nonmetal, or you could think of it as a cation and an anion. And in this particular case, you're going to be dealing with compounds that might contain polyatomic ions. And so these are all things that we need to consider as we walk ourselves through this and talk about how would we go through and actually write the formula if we're given a name. All right, now I'm going to provide with you the rules just kind of like I did before, and then I'm going to walk through two examples with us today. And the first thing we need to do, kind of similar to our naming piece, was write each ion first, right? So you look at the name, identify what the ion is, right? And it's going to be important that you keep in mind that you should have a positive and a negative ion because it's an ionic compound. And based on the name, the positive ion's already going to be first anyway, but make sure that positive ion is written first. That's step number one. Step number two, this is something that we need to consider in this overall process, is that when you look at the charges on your ions, when it forms a compound, it needs to add up and equal zero, right? If it doesn't equal zero, then it's not a neutral compound, which is what we need to have for ionic substances. So the sum of the charges of your two ions needs to be zero. Now, there are going to be a couple ways that we can achieve that. The first way is if you look at your two charges and they simply cancel each other out, like one is positive 1 and the other is negative 1, well, plus 1 and negative 1, that equals 0. You just write the symbols and you move on. If you run into a situation where the charges don't cancel out, so let's say you've got a plus 2 and a minus 1. Well, plus 2 and minus 1 gives us plus 1 left over. We need that to cancel out. So what we're going to do is we're going to say, okay, I'm going to take the numbers of the charges, I'm going to crisscross them and make them the subscripts for the opposite element. Okay? And by crisscross, I just mean simply you're going to move them over and make them the subscripts. We'll walk through an example, so we'll see that in action. And lastly, as you're going through and doing this, if your substance contains a polyatomic ion, so it contains one of those ions that's on your list, and let's say you happen to have more than one of them, right? Like you need to say that you have 2 nitrates, for example, so that's NO3 1-. I need 2 of them. When I write the overall ionic formula, I'm going to need to put that formula in parentheses to make sure that the 2 goes to both the nitrogen and the oxygen, not just the oxygen, right? And again, I've got an example where we're going to get to see how this works itself out. So these are the rules, the things that we need to keep in mind when we're writing the formula. Now, if these are the rules, let's look at a couple of examples, 2 examples of how we would write the formulas based on the name. All right, so here's our example. We've been given potassium chloride, right? That is the name of our compound. And so we just want to look and make sure, is this ionic? Does it contain a metal and a nonmetal, or a cation and an anion? So look at potassium. Potassium's element K. It's definitely a metal. Chloride. Now, there's not going to be a chloride on the periodic table. This is where you have to kind of go back and use what we learned about naming to go back to, okay, chloride, that means it was second. That means we changed the ending from whatever it was to IDE. So chloride looks an awful lot like chlorine, which is the case. So the first thing we're going to do is we're going to write each ion and put in the positive one first. Now, based on the name, we know it's going to be K and then Cl. Now, we have to write them as their ions. And so if you think back to previously in this unit, we looked at and we talked about how we could determine the charge of each ion. We saw that potassium's in group 1. That means that potassium forms a 1+ charge, right? It loses 1 electron to become stable. And then for chloride, or chlorine here, it's in column 17. And we know that column 17 elements want to gain an electron, so it's going to have a 1- charge, right? I'm going to encourage you, go back and look at the slide that talks about oxidation states based on columns. That's where I pulled these numbers from. Okay, so we got a 1+ and a 1-. So we've written them. Now the overall charges, we've written the ion, positive and negative, positive first, and we've got the numbers that are associated with it. So we know that the overall charge has to add up and equal 0. Well, based on what I've got here, we've got +1 - 1, that equals 0. So since the charges just simply cancel out, I can just write the symbols of those two elements to make my chemical formula. And so that's going to leave me with KCl. That would be my chemical formula for potassium chloride. We didn't need to crisscross anything because the charges canceled out when we added them together. And here, we didn't need to use this step because we didn't have a polyatomic ion. So our chemical formula for this compound is simply KCl, right? So pretty straightforward. Let's look at a second example. Now, this case, we've got magnesium nitrate. Right, again, we want to check to make sure that it's ionic. And so we got magnesium, that's Mg, that's a metal. Nitrate ends in ATE. It's not the IDE ending that I'm expecting. So when I see this, when I see that 8 ending, that lets me know this is probably a polyatomic ion, right? So first things first, I write each ion, putting the positive one first. Now magnesium, it's directly on the periodic table. It's in column 2. You look back at that oxidation state slide, and that's going to tell us that we've got a 2+ charge on magnesium because it's in group 2. Now nitrate, it's one of our polyatomic ions, so we need to go and we need to look at that list explicitly to pull its chemical formula. Now, if you look at that list, you look at those polyatomic ions, we see that the chemical formula for nitrate is NO3 1-. Right? So I've written my positive ion first, Mg, and then I've put my negative ion second, NO3 1-. All right? Now again, second step, overall charge must equal 0. Now, in this case, if I add those two together, I've got 2 for magnesium, and I've got 1 for nitrate. That leaves me with a 1 left over. So simply combining magnesium and nitrate together doesn't cancel out the charges. So I can't do step 1. I can't do this. This doesn't work for this particular example. So then I have to go to this kind of second step here, where I need to crisscross the charges to determine the subscripts, how many I need of those other elements. So this is what I'm going to have to do here. Now, when I do the crisscross, what that means is I'm going to take simply the number, and I'm going to say, okay, I'm going to make that the subscript for the other substance. Okay. Now, if I do that, I'm going to end up with an Mg, and just for the sake of this, 1. And then if I just simply write it like this, it'd be NO3 2. Now remember, because we're dealing with a polyatomic ion, NO3, because we're saying that there are going to be 2 nitrates, we can't just write this as Mg1NO32. That's not going to work. We have to put the NO3 in parentheses. So then this would become, and we can ignore the 1, it's not necessary. We can just simply say Mg parentheses NO3, close the parenthesis, and then a 2 on the outside of that parenthesis. And then that, ladies and gentlemen, would be the chemical formula for magnesium nitrate. Okay. And so, ladies and gentlemen, that's how you would go through and you'd be able to write chemical formulas based on names for ionic substances. And like I said, this is the last video for this unit. So after you've watched this, you can go work on the practice for naming for ionic and covalent substances. You might even want to work on that review one to help you prep for the test that's coming up. So thank you guys for joining me today. I hope this video was insightful. Hopefully it's going to be something that helps you and kind of reminds you of the steps that you need to take in order to do this successfully. If you have any questions, please don't hesitate to ask, and I look forward to seeing you guys again soon. Take care.